So what we're going to start with today is, well, at the end of the last lesson, we were talking about trig functions. And I just want to do one or two things more before I move on from that, because I feel like we were making progress, but we just want to consolidate that. And just to sort of remind you of the basic structure. Ooh, let's see if I can draw this properly. A cos, and then we can go B x plus C plus D. Each of these things transforms the basic graph in some way. But let's use a different color for that one. So just to remind you that A is what we call an amplitude change, and the amplitude will stretch the graph up or down. If there's a minus sign in front, it reflects the graph over the axis. B is about period change. C is about horizontal shift. D is about vertical shift up and down. And for sine and cos, the periods are 360, and the range is between -1 and 1 for the normal graph. Tan is a little bit different. The periods are 180, and the range is essentially infinite. It's any real number. But it does have these asymptotes that occur every 180. And then what else? Oh, for step size, we spoke about this. For step size, you just take what the period of the graph is, and sometimes you have to adjust that and divide it by 4 for the sine and cos graph. But if you want the step size for the tan graph, you take the period. It's normally 180, but not always, because there can be a period change. So we say the normal period and divide it by 2. Give me a thumbs up if most of that sounds familiar from the last lesson. Give me a thumbs down if you're like, what are you talking about? So if we look at this theory note, what do you need to know? You need to know the basic shapes of the graphs. You need to know the effects of A, P, and Q, okay? You need to know, this is sort of normal stuff. And then the other thing that we used a lot was we used our calculator, and we used the table mode on our calculator. So give me a thumbs up if you know how to use the table mode on your calculator. Thumbs down if you don't. Okay, so we want to have our calculators ready. Let me get my calculator on standby. So just to show you, I have it. And so I'm ready to do my trig graphing. Okay, let's look at a past exam question. So that's quite a mouthful to start with, but let's just have a look. So it says, sketched below are the graphs of G and the graph of F. So let's actually put that in green, and I'll put the rest of F. I mean, G is in yellow, and they've labeled these graphs wrong. I'm just seeing that. So G of X is the sine graph. Can you all see that? So if we look at the graph here, it says F of X is sine, but here it says G of X is sine. So let's just make sure that we can connect which one goes with which graph. So how would I recognize which one? I'm going to color in the one that's yellow. So yellow is the sine graph, and it's been shifted. I think that this is the yellow graph. Take a moment to look and see if you agree with me. And then I think that the green one is this one. Give me a thumbs up if you agree with me, because that looks like a cos graph. And the periods change. Yeah. Okay. Give me a thumbs up if you agree with me with my coloring in. I don't like these labels. I think they're wrong. How did I know? Because I know the cos graph generally starts up here Okay. And if I look at this one, there's been a period change and an amplitude change, but there's been nothing else. So that fits the shape, whereas this one over here fits the shape of that. So what I'm going to do is I'm going to put that as a g and that as the f function. So, oh, that is right. F is the green one and g. Okay. Thumbs up if you're with me. All right. I want you to try and work out what do you think A is from here? There's the A. What is P? What is B? What is Q? And you have to look at the graph and think about what you know about trig graphs and try and tell me what you think A, P, B, and Q are. And if there's any questions, I'm open for questions, but let's see in the chat. So welcome to, I see Livu has joined us, in Jabulo, Pila, Reniwe, and Tenda, who've also joined us. It's good to be with you. Now, A is the amplitude of this yellow graph. So how are we going to figure out the amplitude? Well, let's think about what the highest point is here and what the lowest point is. Is there a way that this can help us figure out what A is? Let's have a look at the chat there. I heard a message. No, maybe it wasn't a message for me. Oh, Bukle, there we go. Your hand is up. Let me go to you. Can I unmute you? What have I done? Sorry, Bukle, I'm being a bit... Can you hear me? Oh, there we go.
A normal sine graph starts at 0, so I'm guessing that there wasn't a change in amplitude, but just a change in the vertical shift, I guess.
Okay, I sort of get what you're saying, but the problem is this graph goes up and it goes down. And what I know is this plus P is what's called a horizontal shift. So I just think the sine graph has shifted to the left. So that's why it looks a bit like it's in the wrong part of town. But it actually does seem to go higher than normal. Like if I look at this, oh, did I get rid of something? Now, hold on, let me put it back. So if I look at this graph, I think that the highest point it gets to is 2, and the lowest point it gets to is -2. Now, the normal amplitude, it would go up to 1 and down to 1. And so I'm going to say that A is, in fact, 2. Can I have a thumbs up from anybody in the house who feels like they're with me? Thumbs down if I lost you. So the trick is to do this. It's to say, look, take the max value minus the min value and divide by 2. And then you will have the correct number for A. You just need to make sure that it's not a minus. Like sometimes if the shape says it's a minus, the number could be a minus. But here I went 2 minus -2 divided by 2, which is 4/2, which is 2. Okay, now what is the horizontal shift going to be? There's P, and this is a horizontal shift. How much has the graph shifted? And then we can decide if it's a positive or negative. Anyone have any ideas? How much has the graph shifted? And what would I look at? It's shifted 30 degrees, yes, because I know normally it would go through 180, and instead it's gone through 150. So that makes me think it's gone 30 to the left. Now, how do we describe 30 to the left? So it's normally like here when it crosses for a normal sine graph, but instead it's here. How do we go 30 to the left? It's going to be plus 30. Yeah. So this function is y equals 2 sine x plus 30. That's the yellow function. All right, now I want to know, what is b? What is b? So I'm looking at the green graph. What changes are there? Amplitude and period. So how did we work out the amplitude before? We said the biggest value, so max minus min divided by 2. So what's the biggest? 3 minus 3 over 2, which is 6 over 2, which is 3. And I can see the shape has not reflected, so it must be a positive number. So it is going to be 3. Okay, one more to go. What's Q? I see Cullen and Kwande are on it with the B's there. What about Q? Q is the period. So what am I going to look at there? Where does the cos graph normally... This is a bit more tricky, yeah? So to get the new period of the graph, you're going to have to take the old period or the regular period of the cos graph, which is 360, and divide it by some number q to get the new period. Now, we have to look at the graph and go, what is the period of this green graph, this cos graph? What is the period of this cos graph we see in front of us? What should I look at? Remember, when we draw these graphs, they go in quarters, don't they? So maybe we can go backwards. How long is 1/4? That, for me, feels like 1/4 of drawing the cos graph, which is 180, which means what is the new period of this green cos graph going to be here? So this is going to be 720, because think about this, down, down, up, up. So it would take 720. Now we need to figure out what Q is. So we're going to get 720Q equals 360. And then Q is 360 over 720. So it is a half. So Q is a half. Now that is tricky, but just think about this. Remember, when you get the period of the graph, you go 360 divided by a half, which gives you 720, which is the period of this graph. Now, I think some of you would have struggled with that, but just re-watch this. Or are there any questions about how I did that one? Otherwise, give me a thumbs up if you feel like, even if you're a bit like uncertain, you sort of followed the process. Okay. So next part of the question, we're just going to do this one and then we will move on. So you've got A, P, B, and Q. I want you, so you've got, let me write out what the equation of the green one is. It will be y equals 3 cos a half x. So we have got the yellow graph and we've also got our green graph. And this was the function f and this was the function g. So it says, if the graph of the g of x, so which one was g? G is the yellow. So if the graph of the g of x is shifted down by 2 units, write down the amplitude of the new graph. So what is the amplitude of the new graph if I take the yellow one and I shift it down by 2 units? what would that look like? It would be y equals 2 sine x plus 30. And what would cause it to shift down? I would put a minus 2. So what is the amplitude of the new graph? It's a bit of a trick question. The trick question is because the amplitude is the number in front. And since the number in front hasn't changed, the amplitude would still just be 2. Perfect. And I kind of stole the thunder of the question in the next one because it said write down the equation of the new graph. Well, it's just the old equation and then take away 2 because you've shifted it down by 2 units. Give me a thumbs up if you followed that bit. Okay, so it's just if it's a vertical shift, we'll do that. Okay, now it says, last one, if the graph of f of x, so what is the graph of f of x? It's this green one. So if the graph y equals 3 cos a half x is shifted to the left, is shifted 60 to the left, write down 2 possible new equations of the graph. Okay, I'm going to do this one for you because it's a bit weird, but basically what you need to do is, for this new one, if you want to shift something, okay, you are going to have to get the x by itself. And so if it says shifted 60 degrees to the left, well, 60 degrees to the left is going to be x plus 60. Now the half is still there. I've just done this shift over here. Give me a thumbs up if you are with me. Okay, so I'm just going to leave that one at that. I feel like I've done enough. This question was super tough. What I'm going to do actually is I'm going to move on. I'm not going to do any more trig graph questions. You can practice that in your own time. I want you to practice some general solution questions. So your very first one that I would like you to do is I would like you to solve this trig equation for me, and it's a 3-step process. The process is reference angle, quadrant, answers. I want you to do that for me, and then we will start doing a couple of other types of harder ones. We're going to build up to this first. And just put done in the chat when you're done. Okay. So the important thing for step 1 is when you're finding a reference angle, you need to ignore the negative because you take care of the negative in step 2 with the quadrants. So shift tan 0.7 and I get 34.992. So 34.99. What quadrants is tan negative in? it's negative in the second and the fourth quadrant. Please put done in the chat when you're done, so I know that you've got your answer for this one. Okay, and so then step 3. Now, normally with a trig general solution question, you do have 2 answers. So you'd have quadrant 2 and quadrant 4. And it's not wrong to put both answers. But in the case of tan has a period of 180 degrees. And so just in the case of tan, whatever answer you get in quadrant 2, it's repeated 180 degrees later here. So you don't actually have to do it. So you'll get x is equal to 180 minus 34.9. So minus 34. So I get 145.01 plus k times 180, where k is an element of z, or integers. Now, if I did quadrant 4 solution, all that would be is it would just be 145.01 plus 180. And I don't have to do that because it's included in the general solution. But just in case you're curious, it would just be 325.01, but it's gobbled up by this one over here. Okay, let's move to a slightly harder equation. But before I get to that one, let's do this one. So if we look at what makes a trig equation more difficult is a general solution question. We have to sometimes do a little trick at the beginning to help us. So let's start with this. It says, find the general solution for this, round off to 2 decimal places. What makes this question hard? What makes this one hard compared to, like, say, the first one? There's a sine and a cos. Now, there's a bit of learning work you need to do. What you need to do is find a way to get this into one trig ratio. Does anybody know the trick that you start with to make this only one trig ratio? Or get it to like just one? Yeah. Anybody know the trick, the learning work that allows you to unlock this? I'll give you a second to comment. Change either typing to cos or sine. Co-ratio. Okay, co-ratio is actually not a bad trick, but I have another trick in my toolkit. If I do that, do you all understand what I've done if I've divided both sides by cos? Okay, so now something different. If I go 3 sine x over cos x, that's just this side. But if I have cos x over cos x, that cancels out, and I just get 4. But hold on, isn't there a trig identity that deals with sine x over cos x? What is that the same as? It's tan, yes. So now what I'm going to do is I'm going to ask you, can you please find me the general solution for this trig function? And all of a sudden, the difficult part is handled. Now, it's not done, but I want you to do this and at least have a look at the trick I used there. I divided both sides to change this into a tan equation. Okay, do that for me and see what you get. So a 3-step process. Here we go. Shift tan 4 over 3, 53.13 degrees. Where is tan positive? Here and here. The good news is I don't need to do it twice because it's in quadrant 1. And so x will equal 53.13 plus k times 180, where k is an element of the integers. And wasn't that so? Actually, all the hard work was really in converting it to an equation in tan. The rest is actually, you guys have got this. Give me a thumbs up or thumbs down to show you understanding. Fantastic. You see, so actually, even though it looked big and scary, if you did the learning work, you were golden. Okay, now let's talk about this one. What makes this one tricky? What makes this one tricky? There's so many terms here. Eh? Now, I'm going to show you another trick here. Because in this scenario, there's another way you can solve something like this. So, give me a thumbs up if you understand what I did there. So what I did was I took cos x that was on this side, and I moved it to that side, which means it becomes negative. And it's almost like I'm doing one of those equations, you know, like when I have x squared plus 2x equals 3, and then I bring it to the other side and it becomes like minus 3. I'm using that type of technique now. That's kind of what I'm doing. I'm getting it almost into standard form. And do you know what? Do you agree with me that there is a common factor of cos x now on the left-hand side? What do you think I'm going to do if it's sort of a equation where there's 0 on the right-hand side and it can be factorized on the left? What should I do based on your previous experience with maths? I was thinking we take out a common factor and then we ask ourselves what's inside. What do you think is going to go inside my bracket now? So I've taken out the cos x. What do you think is going to go here? Well, what's left behind? It's 2 sine x minus what? Minus 1. Yes, there's a phantom 1 here. Okay, now, if I take this one, it feels a lot like a quadratic equation. So I have to say that cos of x equals 0, or 2 sine x minus 1 equals 0. Now, this one over here seems like it's ready to solve. I need to do a little bit of work on this one. What should I do to make this more solvable? Yeah, so we take the 1 across. So you're going to get 2 sine x equals 1. And then I think I'm going to say sine of x equals a half. Okay, it's almost time for our break. But before we do our break, I want you to solve this, just the blue one. I will handle the one over here on this side because it's actually two equations. It's split. But I just want you to solve the trig equation in the blue box before we have our little break. Okay, so let's do our three-step process. Reference angle equals, so shift sine 0.5 is 30. Now, what quadrants is sine positive? Quadrant 1 and 2. So we have two answers. We have a quadrant 1 and we have a quadrant 2 solution. What are my two solutions going to be? Remember, it's a general solution in the question, so we still have to write it out the long way. Okay, so over here, we're going to get x is 30 plus k times 360, or we're going to get x is 180 minus 30, which is 150 plus k times 360. And then we have to have this k is an element of the integers. Give me a thumbs up if you followed how to do this one over here. Okay, now I'll just do this one over here. If you put this in your calculator and you go shift 0, your reference angle is going to be 90, right? So for this one over here. Now for step 2, because it's actually on the thing in between, you can actually think about, okay, there's two places where it's going to be equal to 0. You can either use, just assume, it doesn't actually matter which one you're in, assume it's positive, in which case it's here and here. Or you can think of it, the cos graph, when it's 0. And you'll notice that when is the cos graph going to be equal to 0? Oh, wait, I lie. It's not 90. Or is it 90? Oh, no, it is 90. Sorry. It's here. And then you'll notice the next time it's 0. So if that's 90, the next one is going to be 270. So how do we see that? Well, imagine here, this is the reference angle, and this one is 360 minus the reference angle. And so my quadrant 1 solution and my quadrant 4 solution, it's just going to be x is 90 plus k times 360, or x is 360 minus 90. And you can see this on the cos graph. Like if you go y is cos x, well, if you type in your calculator the cos of 90, what do I get? Cos of 90 is 0, which means that that's a solution. What about the cos of 270? It's also 0. Okay, what is the learning work that you guys need to do? You need to learn how more difficult trig equations require some factorizing at the beginning, and then at the end, it's the normal process. Give me a score out of 10 for how you were feeling about the trig equations we did now. I know they were hard. I did take it up, but I just wanted to get a feel for if you are with me or if I'm losing you completely and you're like, why do I have to do this? Okay, and be honest. All right, you know what we're going to do? We're going to have a break. So I want you to stand on your feet with me, and I want you to join me in taking some deep breaths. Breathe in. Breathe in. Breathe in. One more breath. Okay, then let us shake out our arms. Get nice and loose and relaxed. Shake out our legs. Okay. Roll our shoulders back. Roll our shoulders forward. Okay, and then shake out your arms one more time. Shake out your legs. You want to feel all tension in your body going away. So you want to feel nice and loose, because then your brain will relax. Okay, then you know what's coming next. We're going to get the blood pumping. So let's do 15 jumping jacks in 3, 2, 1. Let's go. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And that is that. Ooh, those jumping jacks still get me. Okay, we have a choice to make now. Choice number 1, more trig equations, and we keep practicing these harder trig equations, or we do some exponents and surds. Please vote in the chat which option you would like to do next. I want to give a choice to the members of the class. So far we have ones. We have 1, 2. We have a 2, a 2, 2, 2. We have 3 2s. The ones were ahead, but the 2s have taken over. Another 2. Oh, 4 2s. 5 2s. Okay, I think the 2s have almost had it. If you get to 6, don't worry, Callan. This is how democracy works. But either way, you're going to win here. I promise. Okay. All right. It does seem like you guys want to go over some exponents and stuff like that. So let me go to do some of that. But thank you for your voting. I appreciate it. Okay. Let's do 4 quick questions. I want you to do the answers for A, B, C, and D. These are some basic exponential and surd ones. I will give you 3 minutes to do these, and tell me done in the chat when you're done. Okay. Okay. So for a lot of students, it might have been a bit tricky to see this one. Are there any questions about that you would like me to explain further around A, B, C, and D? So sometimes students forget, sometimes writing, like, so for example, B, if you wrote it like this, it's sometimes easier to see why, like, you end up with an x to the 3. It's because of the x to the 5 and the x to the 2 there. And why you get y to the 4, or you have y to the 8 divided by y to the 4. Okay, so that's some basic thingy types questions. Let's skip that one for now. Let's just check with you know what this means. Okay, give me an answer to this one. What does 3 to the minus 1 equal of those 4 options? So it would just be 1 over 3. So it's important that you know this, that if something's a negative exponent, you can change it. Or if I had something like that, that's the same as that. Oh, my brain sent the wrong message there. Okay, let's see. What about this one? What is 4 to the minus 2 the same as? Which is, yeah. So watch out for those ones. Okay, let's find something a bit more tricky for you guys. Can you simplify? No, actually, that's not hard. It's just moving things around. Let's go. Can you please try and evaluate those two without a calculator? So you have to evaluate these or simplify them without a calculator. I'll give you 2 minutes to do that. It tests your understanding of the exponential and surd laws. Okay, how do we do this? Well, I'm going to apply this power to these three. So I'm going to get 8 to the 1/3, a to the 6 times 1/3, b to the 12 times 1/3. In this scenario, 8 is 2 to the 3. This is going to be a squared, and this is going to be b to the 4. What is this final thing here going to become? I think that this is just going to become 3 over 4. So that becomes 2a squared b to the 4. Now, with the second one here, we have to go from surd form to root form. And all we're going to do that is do that. And then what we're going to do is we're going to change the 32 into something more helpful. What do you think I could change the 32 to be more helpful? This could become 2 to the 5, in which case, by the exponent laws, that cancels out. I get 2 to the 2, and then that is the same as 4. So a lot of exponents and surds is about being able to change from surd form to, say, root or to power form, or how to apply the exponential laws or break down numbers that are big into their prime bases or their prime factors. Yeah, let's see if I can get another one in. Let's see here. I don't want to do that one. Don't want to do that one. Let's try this one. Can you simplify this and leave it with positive exponents? So simplify and leave with positive exponents. See what you can do there. So there's two ways that you could do this, but I think for a lot of you, converting the cube root to the power of 3 would be helpful, although you don't have to do that. Then I would say that I would rewrite all of these. So I would break these numbers into their into smaller numbers. And then what I could do is I could, a third, which is outside, will get applied to all of those, and it will get applied to all of those. And so I get that, I get that, and I get that. So what have I got now? 3ab squared over 4 times c3. Some of you might have said, look, that seems awfully long to get there. I can just find the cube root of 27 is 3. The cube root of a to the 3 is a. The cube root of b to the 6 is b squared. The cube root of 64 is 4. The cube root of c to the 9 is c to the 3. So some of you might have just done it in one step. Both ways, though, give us the same answer. Thumbs up if you understood that. Thumbs down if you didn't. Anyone? Thumbs up, thumbs down? Okay. Thanks, Naledi. Thanks, Bukle. Let's see if I can find you something else that's a bit interesting. Okay, that is fine. Let's go to, okay, here we go. So we're really starting to get now into the more exam type questions. Now we need to talk about strategy. What strategies can you remember for dealing with when you've got a multiplication on the top and the bottom and you've got to simplify? What strategy, and you can use an audio like thing now or the chat, but strategy is very important. We have to simplify this expression. Okay, Bukle, yes, thank you for your keenness. Bukle, what do you think we should do?
We'd have to simplify these values into their prime factors first.
Yes, so the 6 and the 9 and the 54 and the quarter should be broken down into smaller numbers, and often it's primes. So what I like to do is I like to leave a space for the thing that I'm going to break down, because it leaves me time and space to break it down. And I want you to go in there now and write down what you think we should break it down into. And then once you're done, just put D in the chat so I know that you've made your decision. So just put a D when you've made your decision about what. This first one is not too bad. 2 times 3. And this one could just be 3 squared, or 3 times 3. 54 is a bit trickier, though. Maybe I should go back to the ladder method from grade 7. Oh, there we go. I can see what's going on here. Sorry, grade 8. 2 times 3 times 3. Okay, so I'm going to go 2 times 3 cubed. And here, a quarter is the same as 1 over 2 squared, but then I'm going to bring it to the top. Thumbs up if you're with me so far. Thumbs down if you're not. What is my next step going to be? How do I, now that I've broken down and I've only got 2s and 3s, which makes me very happy, what should I do next? In fact, you know what? I'm going to let you try and get the final answer. Why don't you try and do this? I'll give you 2 minutes and then we'll finish with this question today. See if you can work it out. Why did I change the 3 to a 2? Ooh, let's have a look. Did I get excited here? 3. Ooh, I just made stuff up. Well done. Well done. This should be a 3 to the 6x. Did I change anything else there? No, that's good. But somehow I changed it. Okay, so let's do that. Then I get 2 to, in fact, thank you very much for spotting that. I should get 3 to the 12x. Thanks, Akwande. And then what I'm going to get on the bottom is I'm going to get 2 to the 6x. I'm going to leave that like that, and then I'm going to leave that like that. Okay, things are looking promising because 2 to the 6x over 2 to the 6x is 1. 3 to the 12x over 3 to the 12x is 1. So now I'm left with 1 over 2 to the minus 4. Can I simplify that? I think I bring it to the top, and then I could leave it like that, or I could say 2 times 2 is 4 times 2 times 2. The final answer is 16. Okay, everyone. What are we going to do in our next lesson? Okay. We are going to carry on with exponents and surds. I think I can see that you guys would like to carry on doing more of these questions and some exponential equations. So I will carry on with exponents and surds, and then we'll take it from there based on the needs of the class.